Welcome, everybody. Fabulous to have you.
Thank you.
Thank you each for joining us. By way of introductions, everyone, this conversation is between Michael Murphy, who's the Senior Product Manager, Edge and 5G APIs at Vodafone. We also have, welcome Michael, we have Luc-Philippe Bouchard, Senior Solution Architect, 5G MEC API Service League at Bell.
Don't hear any sound yet.
And I think Luc-Philippe may be on mute.
I'm all good.
I can hear you.
There you go. Welcome. And we have Troy Saulnier, Network Strategy at Bell. So really excited to hear about your talk between the three of you on 5G FF.
Excellent.
To you all soon. Thank you.
So welcome. I'm gonna kick this off. As you already introduced me, my name is Michael Murphy. I work for Vodafone Group, and I am the Vodafone delegate or representative to the 5G Future Forum, which is 5GFF, where you see the logo there. Today's topic, as you already mentioned, is how APIs are fueling growth of 5G and MEC. And I'm just going to go ahead and explain its multi-edge or mobility edge compute service. So now that we see MEC, it's because it's going to come up over and over. We're going to do this from the perspective of the 5GFF consortium and what we're trying to achieve. I'm going to provide an overview of the organization, our mission, and some of the work we've done thus far. And then I'm going to hand it to my colleagues from Bell Canada. They're going to go through some of the underlying technology we're going to reference, as well as the 5GFF API roadmap, and they're going to cover that in a lot more depth. So next slide, please. So what is 5GFF? We're a global consortium of telecom companies founded in 2020. Our focus is on mobile edge compute services delivered via 5G networks and the supporting ecosystems. So all the things that are going to be needed as APIs are rolled out to access these services. And our mission is to accelerate the delivery of these solutions to developers and customers globally. We're going to try to achieve this through the 5GFF APIs. Some of the things they do are allowing seamless discovery of the edge locations, deploying workloads on there, orchestrations of the applications on the MEC environment, but doing that hand in hand with the telco network. We have 7 members around the world, as you can see the logos here. We are American Mobile, Bell Canada, Korea Telecom, Rogers in Canada, Verizon, Vodafone, and Telstra. As you can see, we're quite geographically diverse, but our diversity also provides us a broad foundation of knowledge and insight to develop these APIs into common network standards. It's a common goal amongst these disparate networks. And the end goal is just to make these easy for software developers to implement these simply. That's the key, really. Next slide. So I just want to cover a couple of the basic terms we're going to go over. So what is MEC? So MEC, as I mentioned, is multi-access compute, and that is a cloud-based solution that's implemented at the edge of the radio network, and that's as opposed to a central cloud service like a typical Amazon Web Services, or even an own private data center somewhere like a telehouse somewhere. Because the data is processed and stored at the network's edge, it significantly reduces latency, and that's going to be covered in a little more detail in the technical section. But it's like having a data center on your edge device. Data localization also allows for some other efficiencies, including bandwidth efficiency, which may significantly impact in a positive way users of the infrastructure. So saving a lot of transport. The members of 5GFF have chosen to deploy MEC with Amazon Web Services initially. That's called Wavelength. But that's not the only compute edge model. And indeed, as we're going to cover in a second, it's the idea is to really make it agnostic to the cloud provider. So how do network APIs support the MEC solution? They allow for real-time information exchange and provisioning of service between all of the software infrastructure elements. As you can see there, it's between the MEC, the platform, the end device, the whole thing from end to end in the compute service. So excuse me. So this is new, and these functions were not previously available on mobile networks. So how does 5G fit in? What's the impact? Well, it facilitates lower latency from a network perspective. Again, that will be covered in a little more detail later. And it also enables network functions that were not previously available to developers, essentially allowing for network-aware applications. And finally, how do 5GFF APIs support this new technology paradigm? Well, in creating the standardized APIs, we're hoping to unleash the potential for developers to interact and utilize telco networks across the globe. There are literally hundreds of networks using a wide range of underlying technologies and providers. Using a standard approach will have a huge impact on developers' ability to scale across networks globally. Next page. So the demos. So I'm going to reference 2 demos we've already done. At Mobile World Congress in Barcelona in February, we worked together with a company called a developer platform called Open Sesame. So Open Sesame provides low latency synchronized applications to developers via its SyncStage audio platform. In short, they sync a group of users at extremely low latency to enable real-time collaboration. And I know that's a lot of buzzwords, but to actually get musicians to play at disparate locations, if they're not almost entirely in sync, then they won't be able to play together uniformly. They'll go off and as if it's a different jam session. So latency was one of the key metrics and importance to them, and utilizing the MEC service for that. And so next slide. So here's a bit of the architecture. But what they did was we were using 5GFF's Edge Discovery Service API to create this. And sorry, if you go back one slide, I apologize. So again, what we did is we had musicians playing in 3 separate locations. You can see New York, Toronto, London. And the idea was we showcased a rock festival put together, but it was all done live, really showing the benefit of how this application could work in the real world. Sorry, next slide. And just real quickly, here's the high level architecture. You could see using the MEC service, we experienced about 14 to 25% better latency from the cloud. That's by deploying the application at the edge. But what this also demonstrates is the interoperability, right? They were able to call APIs from 3 separate platforms using the same standard API, and they were able to interoperate across all the networks again to seamlessly come together, leveraging a central software platform. And if you'd like to learn more about these particular sessions, we have the Open Sesame white paper. There's a demo on the 5GFF website, the whole video that was taken of the session, as well as an AWS white paper talking about interoperability and the importance of that. We're also going to cover a little bit later. There was another demo at the previous Mobile World Congress in Las Vegas back at last September, and that was with Summit Technologies using their Audience platform. That's going to be covered a little bit later in the technical section as well. Next slide. So now I'd like to hand this over to my colleague, Troy, Bell Canada. Troy, take it away. Oh, we get the whole presentation. There we go. Off mute, please.
Yes, apologies. I was carbon unit interface problem. In any case, it's my pleasure and my colleagues' pleasure to be here with you folks today. Hopefully you find this useful and it sparks some great discussion. Looking forward to the Q&A. So what makes 5G different? We thought it would be good to at least give you a bit of a primer on some of the technologies that we're talking about here. You're likely very familiar with, the constant progression of new Gs. And in the past, it's always been, from the time where we had no data to just starting data, increasing the successive bandwidth that's available to use on your handset for whatever applications you're using. With 5G, it increases that, tremendously more, largely due to the fact that there's a whole bunch of spectrum that's been unlocked globally around the world. But in addition to bandwidth, there's also other metrics that are meaningfully brought forward. So increased availability, increased coverage, also a lot more devices supported, especially as we get into MMTC. I'll talk about that a little bit. And then a lot less energy as well for IoT type devices. And then latency, as well as the variability of latency, so jitter, are also all aspects that we're going to see big improvements on. And you can see some of those examples over on the right, like immersive entertainment, safer transportation with telemetry for autonomously guided vehicles, sustainable cities, and public safety. But the real kicker here, the takeaway is that the real difference with 5G is this interconnection and this convergence of leveraging cloud, all the developments in AI, and the APIs, so that we can bring together this ecosystem and have independent software vendors, ISVs, and developers collaborate with operators around the world to create this sea of new opportunity in terms of new applications running on the network with these new capabilities. And so some of the examples of some of these use cases, I've put them into three categories here. So enhanced mobile broadband is a continuation of mobile broadband that's available in 4G and LTE and LTE Advanced. So you'll see fixed wireless broadband, great use case, especially with all the extra spectrum that's been deployed. Immersive entertainment, that really relies a lot on low latency, but also bandwidth. And just regular data growth. Massive IoT, you may hear when we talk about slicing for 5G, this idea of EMBB slice, which all operators have today. You'll have an MMTC slice eventually as time goes on, and then also a URLLC slice, which is for ultra low reliability and latency. And you see for the massive IoT, smart cities, environmental monitoring, logistics, and low latency, of course, mission critical services like drones, where you might be using them for disaster recovery or when there's a large weather event. We've recently had, unfortunately, some wildfires here. So, those kind of things are really useful in situations like that. Autonomous guided vehicles, either, consumer or industrial, and then even remote healthcare. And in the previous slide, we talked about all of these examples, but that's what they were. They were examples, concepts, ideas. But we're moving forward with real companies, real business objectives, and enabling breakthroughs from an innovation perspective. And so whether it's virtual shopping that's enabled through 5G and MEC that you see over on the left, or whether it's the work that we did with TinyMile, you'll see the cute little pink food delivery robot in the middle, or whether it's delivering packages with Drone Delivery Canada. All of those were delivered through POX using AWS as well, in some cases also Google's GDCE environment, all connected to Bell's wireless network directly. And as part of this shift in the ecosystem, what we're seeing is we're moving from a scenario where every user had pretty much the same experience, right? So it was, we're as operators, we're engineering for the best network for everyone, versus in the future, we'll have a differentiated experience that will come largely through slicing or through, setting specific RAN parameters, changing your routing, and so on, or which MEC site you're connected to. But each user, their experience, their performance of their network connection will be tailored for the use case in question and the user in question, so that they get exactly what they need, right? Versus over provisioning for everybody, right? And then the other aspect is we want to go from mass consumer features, so everybody gets, these bunch of features to multiple targeted solutions. So really, no longer just a widget that's being delivered from a catalog, but a targeted solution that's really solving a business problem. We're seeing that kind of change as well. And then lastly, primarily it's been consumer driven. Of course, there's a big enterprise business as well in wireless, but we're also seeing, we know, and I say we, like the whole ecosystem of operators knows that we can't do this alone. And so that's why we're here today at API Days. We're going to need all the really smart heads of the folks that are listening to this and hopefully become interested to collaborate with us. And so developers and enterprises are another big part of this as well. And you'll see that we go from just a consumer user to ports, rail stations, logistics, industrial IoT 4.0, transportation. All of these verticals now become addressed, but we really need the developers to work with us. And that's going to cement our journey from telcos providing communication services to servcos or techcos delivering solutions to their end customers. So just a little second on latency. And the reason we bring up latency is because the piece of technology that addresses latency the most is MEC, and we're talking about APIs for 5G and MEC. So if you think about latency, you can define it many different ways. When we're talking about it, typically we were talking about it from a return trip perspective. So that's from the end user that makes the request all the way out to the network, to the content that they're trying to get access to or the application, and then the packet all the way back. And so in the examples that you see here on the screen, in terms of guided vehicles, having access to telemetry before they arrive helps the actual onboard systems be more efficient and safer. From a stock sale perspective, obviously latency is hugely important. And then you can see many other applications down at the bottom: drone control, high precision autonomous mining, XR. The whole announcement that you've, I'm sure, recently heard from Apple, what Meta's doing. I think there's a lot of huge development in the spatial computing or XR space. And then the other one would be 360-degree sports and esports. Bell has a service in market called 5G View, and it allows you to look around, the entire court from many different camera angles and pause, play, rewind, look at players' perspectives and so on. So a little bit on the technology from a MEC perspective. So if you think about the way our network is deployed today or before MEC, we essentially had a bunch of global data centers, so very large data centers and big concentrations of population. And if you were in that center of population, great. But if you're a little bit further away, or if you're in a city that's not at one of the pops, then what you're going to have to do is your packets will have to transit through an edge CO, a local data center, a global data center. There may be many intervening nodes. This is a simplified view in between, right? And so by moving the compute as close as you can to the customer, as close as you need to the customer, in some cases a far edge close to a cell site or on a venue like a stadium, or in other cases the last serving CO, then you remove all those intervening nodes. And so you really are left with the air interface between your UE, your device, and the actual tower, slight amount of transport, and then the edge CO where you would actually have your MEC site. And at this point, I'd like to hand it over to my esteemed colleague, Luc-Philippe Bouchard, who will take us through some of the more technical details. Over to you, LP.
Thank you, Troy. If you want to just, thank you, Troy. Thank you, Mike. So I'll start with this one. Having an R&D and developer background before I joined Bell, I know how sometimes difficult it is to understand and access some of the network features. So our journey here starts with the top layer. So the partners we have in mind that we want to work with and we are already working with. And this can be independent software vendors, ISVs, it can be individual developers, enterprise customers, and so on, so that we can support different types of use cases, B2B or business to business, B2B to X, depending on the case of drones, for example, and of course, the consumer market, B2C, the more familiar one. All these different business segments do have maybe some interfaces they are used to using, are there for charging. So we are leveraging those interfaces. We're leveraging those portals so that we can actually focus on an API layer, what you see in the middle. We have a number of them, but we will focus through 5G FF on what we're exposing for core and RAN, data, cloud, MEC, and of course location. And I'll go into some of the features there when we talk about the roadmap, and I'll explain a bit what they mean. The reason we're building this API layer, of course, is so that we can expose those super value added benefits and attributes that Troy and Mike mentioned, like bandwidth, not just for download, but also for uploads. Very important. Sometimes video is very demanding on the upload. Latency, as we mentioned, jitter. Basically, jitter is the stability of your network and the predictability of your network, so it doesn't have variances. We hear about quality of service, so you can actually have a reserved guaranteed bitrate, for example. We talked about quality on demand, so you can actually maybe demand a boost for a temporary period of time. So all these things and more, congestion, network behavior, location. And we're doing this more and more so that we actually cater for the use cases. And that's maybe where 5G and 5GFF come into play, because of course we have all these great features that some of us know about slicing, about 5G, about fiber and MEC, but what does it mean for developers? How do we know if it's beneficial to them or not? It really depends on the use case. And that's why all these categories we talked about have been identified and focused on by different working groups so that we can actually bring that value to the developers. Next slide, please. Right, so as we're building this, it's an ecosystem play, as we said. It's not just one operator, it's a multitude of operators. It's not just one equipment vendor, it's multiple equipment vendors. It's not just one cloud provider. It's, like I said, an ecosystem. We have to work as a whole here as much as possible so that developers, when they develop one application, it can run in multiple different locations, pretty much the same way with minimal friction. Of course, we talked about the benefits of MEC, and emphasize one little thing that my colleagues didn't mention yet, but it's got also an impact on form factor. You can reduce your cost, your weight on the device if you bring the compute to the edge in lieu of on the device or on the core network. So huge benefits there too from a form factor perspective. Ecosystem, of course, there's that portal environment that most or many players are building, either for cloud access or for network access, and sometimes both. We have developer sandboxes that are more and more available for people who want to play with the APIs for free, experiment, learn as they go, as opposed to dropping code and then not knowing how it's going to integrate. You can actually do that in some environments with sandboxes. And exposing KPIs too that are maybe less obvious, things like load time, so you can actually anticipate how much time you need to instantiate a different MEC location versus when there's a demand to expand your MEC coverage to another area, for example, and so on and so forth, multiple KPIs. We talked about some of the benefits, of course, of differentiated experiences. Some people will need quality of services, some don't. Some people may need slicing, maybe others don't. So that's the whole idea of building templates or even profiles for those differentiated experiences and having those access through APIs. And finally, last but not least, the whole ecosystem with device and manufacturers is very important to see how they evolve. We are working with a number of providers as a group, either for XR, AR, and so on, even consumer devices, of course, to introduce them to the benefits and work with them to leverage these benefits and tweak the technology as needed. For example, make certain devices more readily 5G available. And last but not least, the whole work around what we are doing here today, network, not just mobile networks, and standard organization, SDOs. It's very important to build that ecosystem, to have that collaborative approach. Next slide, please. So we talked about a typical architecture. Let's use the example of audiences. And the company is called Summit Tech. It's an immersive 360 experience. What it is really, there's a 360 camera in an event location that can capture instantly all angles of a particular scene, like a shopping event, a sporting event, even a personal event, and people at the other end have their own device with a client, and they actually can choose the angle in real time for that particular event. So latency is key because you might want to turn around real quick if it's a sport event to see something specific in the action or in the field of view. And the MEC is responsible for actually computing that field of view based on personalized device requests or positioning. And for other use cases, the edge discovery here, the EDS API was used and was determining the best location for the software provider to deploy their application. So they could, for example, choose a given market, or even expand to another market should the event continue or required in terms of capacity. So EDS is one good example of a demo that was successful through 5GFF and through a group we're working with. Next slide, please. Now, last but not least, it is important to state that it's not just demos anymore. There has been a couple of proofs of concept across networks, but also premieres. It's very early days, but last couple of weeks, June 16th, and there was the F1 Montreal, and there was actually a premiere event using AWS, using Google, and using the audience platform to broadcast a gala, a red carpet event in real time. And people were able to actually experience it for the first time. And so kudos to the developers and the fact that we were able to support them. Next slide, please. Of course, there's learnings. It never comes easy. And one of the reasons we're here too is to work with the developer community to help improve or minimize that friction that we see or we detect when we do these projects. There are so many things we learned and so many things we'd like to automate. One of the ways to do that, and I'm not going to go through the whole list here, it's just it reminds me of a couple of painful moments, but long story short, these are key things that need to happen. For example, for a given developer or ISV to manage their workload, resource scheduling, deploy, and monitor their app. Some of this can be done automatically already, but not everything, and manual work doesn't scale, as we know. And that's why we're very interested and supportive of initiatives such as 5GFF to build that end-to-end API flow so that we can aim for that zero-touch provisioning or low-touch provisioning. Next slide, please. So thus came Kamara 5GFF working in collaboration with the hyperscalers. So I have a bit more on Kamara. They're basically a Linux Foundation-based group that do focus on network APIs and how that can be exposed, especially for 5G features, for example. And us being focused so very specifically on MEC, working together so that we do not overlap, we complete each other's work. Same thing for the hyperscalers. We are working with them on a very regular basis to improve their tooling, but also improve API-wise how information can flow both ways. And we have a bit more on that a little later. This is just a quick view of APIs. We all know they've been there for a long time, older than all of us here most likely. But this is just to point out that 5GFF is not in a vacuum. 5GFF can leverage TM Forum for some parts of what developers do. 5GFF can refer to Kamara for some of the publications that they have, for example, Edge Cloud APIs, as we'll see in a minute, and so on and so forth. So building that ecosystem is in respect of and in reality of what a developer's life cycle has to go through or a developer's journey has to go through. So let's talk about our roadmap in a minute or two. So we talk about a few focus areas for 5GFF. So traffic steering and optimization. So each developer or ISV might have different routing or network requirements. And this API exposes those different types of features or attributes we can make available to them, such as slice or traffic influence or quality of service and demand. Second area we look at is network intelligence exposure or network insights. Very important, once again, to not only look at the stability, but maybe even with AI and historical information, be able to react faster to situations where we detect an inflection of some sort or an anomaly of some sort in the traffic patterns. We talked about bidirectional API a little. This is basically us working with cloud service providers, the Googles, the Amazons of this world, so that we are able to make the developer's life simpler. Either you knock on their door or you knock on the MNO door. We're trying to make sure that the two environments are not in isolation, that they can complete each other so that the developer journey is as simple as possible. And the last two, we talked about discovery. Discovery is essentially, like I said a few minutes ago, being able to determine which location is the best or which location is available, but also where the user may be going so that we can actually prepare the instantiation of a workload in a future location so that when a user is moving from A to B, they're not losing their the richness of MEC. They can actually have their application available on the second MEC location when they get to the B point. And workload orchestration is pretty much self-explanatory. It's for the developers to test, build, deploy, manage, operate, and eventually end of life their workloads. For those last two, we of course are leaning really hard on Kamara because they have done some work for Edge Cloud, for example, where this is already in some cases very detailed and very useful. And we're in addition to that, adding some more telco specific requirements to the API specifications. Next slide, please. So we talked about the journey. So this is, of course, the happy path. If you're a cloud provider, on to the left side, you can join through these APIs the MNO ecosystem as easily as possible. The MNO ecosystem, or the mobile network operator ecosystem, which is in the middle and is on top of the 5G and the MEC stack, is basically there for some form of curation, either for accounts or for structures or for some form of infrastructure management, because at the end of the day, an edge is still a physical server or set of servers in a particular site. So there's a bit of infrastructure management required. Roles and access need to be managed and so on. So the middle layer from the MNO is being automated as much as possible. And that's one of the key benefits of APIs. Last but not least, the developer. So to the right-hand side, developers are there. So like we said earlier, they have their sandbox, they have their portals, they have their APIs they can play around and use to deploy their workloads. So this is what we don't want it to be. This is, and I apologize if I don't know where this come from. I got this from a Slack buddy. This is what a project looked like over time with a number of actors, a number of tools, a number of states in the project or the product's lifecycle. So long story short, we just want to make sure the developer is eco-friendly, developer-friendly, sorry, and not a burden more than it should be. And this is my last slide. So a few takeaways. We are fortunate with what we are working with right now. There's flexibility in the partners. There's various hyperscaler tools. There's various marketplaces available. You can find a fit if there's a will. Agility is very also common. You don't have to necessarily build your application from end to end day one. A lot of 5GFF members and other service providers out there today are very supportive of iterative progressive approaches, or the agile way, where you build as you go. Tooling, we've seen a lot of that grow incredibly over the last few years, and there's more to come. Developers do it, hyperscalers do it, service providers do it. So there's very much a lot of focus, and we need your feedback. It's very important to get your feedback as we build these environments. Creativity is something through the roof. We've seen some very original ideas from not just startups, but also major companies. People coming up with, hey, I can actually leverage network behavior. I can actually reach out a new customer base I never thought I could reach out to before. So it's really releasing creative juices from the developer community, and we're very happy and encouraged to see that. And finally, standards. Standards are very key to interoperate technologies. So we don't want to create walled gardens. We don't want to have isolations or environments where it's more complicated for developers to deploy and operate it. You don't want to have to deploy your code for each network differently. If there's a way to do it, it has to be standardized and simplified. So we're lucky that standards are supportive, and that's what we're doing ourselves in our own way with 5GFF. Last but not least on this slide is all this is going back to Michael and Troy's point. We want to unleash and unlock a lot of value and generate monetization opportunities or generate new use cases that were not imagined before. And I'm technical, so I of course see value as in many ways, not just making money. It's important to say that sometimes you can save money. You can have cost savings. You can improve security. You can improve the user experience of your user. Making these things bring value is done in multiple ways. And that completes my part. I'll just bring it back to you, Mike and Troy, if you want to talk about a wrap-up.
Yeah, thank you. So hopefully that gave some overview from the beginning of what we're trying to accomplish, as well as some of the technical things from the network perspective and the compute perspective and developers perspective, going through this journey with us. One of the things 5GFF is doing is we've initiated something called the MEC Acceleration Program. And what we're trying to do is get input, get input from ISVs, developers, to go on this journey with us. I think it's important to stress that although roadmaps are out there and everybody has a really good, I think, view of where we think we're going to be very soon, a lot of this stuff is still in the developmental stage, right? And as was mentioned earlier, I think by Troy and maybe LP as well, that what we're trying to do is we're not just trying to prescriptively build the APIs without any input, right? The use cases are going to be dependent on the usefulness to developers and their end users, right? So we're actually in the early stages. A lot of this stuff is all being developed and worked on, and there's some consensus. But what this program does is, if you apply for it as a developer, and we'll discuss it with you, and if it's a fit, we'll bring you in. You can be perhaps on some of the technical work stream sessions we have. We're also thinking in terms of doing some, co-creation, do some use cases where we can support each other. And in fact, the next Mobile World Congress in Vegas, one of our participants, we're going to be doing an upcoming demo as well. So chances to participate, chance to influence and give feedback on the ideas that the telcos are pulling together, and ultimately the input will help shape how these APIs evolve, get standardized to be the most useful and practical to the developers. So with that said, I think we've wrapped up our presentation. So we'd like to open it up for Claire, if you want to open it up for any kind of questions.
So firstly, thank you, the three of you, for a fabulous summary of the world of 5GFF. There's been so much about it, so much excitement, I think, in the API world, global community, and really fantastic to get such a great summary of what's such an almost mind-boggling, enormous opportunity, I find. And fantastic to have nearly a third of the 7 startup participants, members, represented, with both of, with Bell and Vodafone here. So thank you, firstly. I'm interested about, from the developers that you're looking to start getting engaged, giving them opportunities to participate. What will that look like for them in the early days? We reckon, fully appreciating that it's embryonic still, and they're working with 7 organizations and across one. What's it going to look like? Feel like?
So actually, I can start first. So one of the things we also wanted to say is, as a consortium, you can approach us as a consortium. And the main key to that is we're talking to each other, and it's about interoperability, right? So if we do any testing with a developer, an ISV, one of the main things we're trying to ensure is it's going to work seamlessly across multiple networks, right? That's part of the benefit. You could also individually approach any of the members and work with their work to deploy an application on MEC, or work perhaps to test both the APIs they've implemented and use MEC as well. So this isn't an exclusive process necessarily, but 5GFF is kind of the culmination where we do the interoperability. And as far as approaching us, is that if in the program, for example, we'll have a discussion, qualify, see what the end goal is, and see which APIs, which services are best going to enable what they're seeking to achieve. So, for example, with Open Sesame, it was very clear they wanted to enable really low latency collaboration across multiple networks, in the hopes of deploying that and having the most users be able to access the platform. So that's how we worked with them and enabled it. Somebody else's use case might look completely different. Troy, JP, or LP, any comments?
Sure. Yeah, Go ahead, JP.
I'll jump in with one. Yeah, I'll jump in. And it's interesting to see that we have a very wide spectrum of participants and interested parties. We have companies that are new to the space, small companies new to the space, but they see the potential. They're interested in the potential, and we can work with companies with that path in mind, or that kind of journey in mind. On the other side, we work with companies that are maybe larger, but also much more advanced in their journey, and we can actually check and adjust and follow a path that's more adapted to their needs, because they will have different needs. They'll have the expert kind of level need, where we actually improve on what we thought the APIs would look like, versus the basic needs, right? We have to cater for a wider range of different players. So we're trying to be mindful of that. Hopefully that helped answer the question.
Yeah, and I just want to add in as well, so what Michael was talking about in terms of engagement models, there's of course the 5GFF, there's the individual operator, but even if you're working with, an individual operator that's a member, the anticipation is that as that work happens, whether it's a POC or a commercial engagement, that we would look to whatever API development is done to upstream back into the community, right? Because that interoperability is so important. Obviously, someone who's a global, software player is not going to want to write 26 different integrations for each operator. That's the whole purpose of this. We really want to make sure that it's a one and done, in terms of the API itself. And then the other thing to think about as well is sometimes it's not, it's like a 3 or 4 parties together can build something really interesting. So we've got cases where we've got an equipment manufacturer, we've got say a private network provider, we've got a drone manufacturer, we've got someone doing AI models, and we really need to be able to control the quality on an on-demand basis, hence the QoD Chimera type of application, right? And those can be really, really interesting. We got others where, you've got AR glasses and you've got an expert directing someone in the field. So you can imagine they need to see what that person in the field is seeing and direct them in real time. Latency is obviously going to be a big constraint. So back to you, Claire.
No, and I think these examples of these case studies that just in terms of one's only limited by imagination, and the idea of and creating this cross collaboration between people to solve some of these big these big problems, or they're small problems that could be solved in a new and creative way. You've chosen the examples you gave of making an impact through launching the capability with high profile events and concerts and sports activities and so on, is obviously a fantastic way to get profile and people to really understand what the potential is and see it in action. What kind of opportunities are you thinking about? Maybe you can't share them, but that might be playing into some of the questions that a lot of people have about the environmental impact of data movement, if you like, which, in the network, probably another 50-minute conversation to even get started. But be curious.
Let me start this one, and then I'll pass it over. Michael earlier on mentioned, the data localization part of MEC, right? And so if for a given application, there's a ton of processing. Rather than actually shipping all those bits to a global data center, if you can process that locally, it can actually save the end user on transport costs. But more importantly, it can help you, in terms of the actual processing that you're doing. You're not doing it in multiple places in the network. So localizing that is actually an important factor. And in fact, often what's done is maybe you'll send the model building part, so the deep learning part, over to the big cloud, and then all of your closed loop where condition happens, take this action based on what the model learned. You do all that locally. So your inference engine locally, and then your deep learning, kind of remote. So LP, sorry, you wanted to make a comment as well?
No, that's exactly it. And I'll complete the thought. For example, video's very heavy on consumption of data. So when you have video monitoring systems that are using MEC, for example, you don't haul the data all the way back to the core network. You're able to just do the last leg between a device, for example, the camera, and the inference center, the MEC, and only pass on the alerts or the anomalies or what you want to detect. So you're saving a truckload of backhaul data, cost, energy in that sense. That's one key factor that is justifying some of the investments we're seeing here in MEC. The other thing may be a bit more hard to quantify today, but I can anticipate that this might have an impact for every consumer out there. You might not need your GPU, your display to run as much, power-hungry compute requirements as you do today, when some of that is happening on the edge. So there may be small benefits there, but if they are done at a wider scale, you can imagine that could save a lot of the energy footprint out there today on battery life, for example, and data power consumption.
Could certainly see how that's a really hot topic for the community at large, or society, if you like, at the moment, is very is seeking positions and case studies and opportunities and ways of thinking. So.
Yeah, and I think a number of
the thing is the fact that we're sorry.
No, go ahead.
We're also involved in different, as we said, Mike, Troy, and I, that a lot of the communities are dialoguing, talking about these new challenges, and this is slowly but surely making its way towards the next G, where power savings, maybe different types of collaborations will be required and built into the specs most likely, so that we consume less power and have a milder footprint on the environment.
Yeah. All I was going to add in was the fact that a number of the members are working with AI and robotics companies to actually try and extract some of that intelligence out of the end device, whether it's a robot or a vehicle, and move that to the edge. It's typically not supportable all the way back to the big cloud, but at a MEC site it is, and that can really change the amount of compute that you need in an individual item that's out in the field, right? So it's really, really interesting.
And exciting times. And I know we're close to finishing up on time. How do you find working in, and I'm curious, as three individuals right at the heart of this consortium, and you're now working as part of a group around the world, all in different time zones. What have you been learning out of the process? It must be exciting environment.
I'll chime in first. First of all, I want to say you could see how extremely polite our Canadian colleagues are to each other. They're constantly, being deferential, but no, it's actually exciting because we're working. We have several weekly sessions. We have technical work stream, commercial work stream, and other meetings in order to support this. And what I can say is everybody, all coming from different companies, everybody is focused on. We understand the opportunity. We understand the use cases. I think some killer apps have to drop to really drive this. But the reason why we're all coming together so enthusiastically is because we all want to see, we've all invested tremendous amounts in our 5G networks and all of these other things. We can kind of see where this is going, and we're just waiting to be able to support this. And also, I'll say one more time, the interoperability is absolutely key. You know, if you have, even within Europe, let's say an average of 4 mobile networks across 35 countries, I mean, for a developer to actually scale that and have to learn different APIs, for example, for each one would be almost impossible. So we're absolutely, I think, all focused on facilitating that ease, because if it's easier for developers, the whole marketplace is going to expand and grow. And we're all there generally. This is what it all is. It's all a general push to support the developer and the programming community, so we can all take advantage of this next paradigm. So, last word from the Canadians. Anybody?
Go ahead, LP.
Thank you. So polite. It's great. It's great because there's a tremendous sense, as Mike said, tremendous sense of collaboration and understanding that the ones that need to win the most out of this are the developers, and the ones consuming or benefiting from these APIs being available, these network features being available. We want to make them empowered as much as we can, so that they can bring those new experiences to the end user, to the consumers, the mass markets, or the enterprises. So it's very stimulating. There's always a new partner that's knocking on the door, or a new startup, or even, like I said, big companies knocking on the door with ideas. So it's very stimulating. But all in all, tremendous collaboration. And since we're also involved in other SDOs or standard organizations, there's a very fluid communication across standardization bodies, which is great, so that we can, again, complete each other's work.
Yeah, absolutely agree. I'd say, like, if you compare it to other SDOs, like a pure standards group, I would say 5GFF is a little bit more concrete, because we want to create real working code. We are going to draw from other standards groups, from operators, from partners, and so on. And it's about making things that work, and that things that work together. So I think it's certainly an exciting journey, and the colleagues have been really great to work with.
Fantastic. And I think that's probably a great way to round up. And thank you each, Mike, LP, and Troy, for putting the time in to give us this really interesting and thought-provoking briefing and update. And we, as a consumer, as a member of the broader API community, we all, I'm watching personally with a lot of interest in the success that I'm sure you will have.
Yeah, we look forward to developers beating down the doors, asking for cool features, and telling us what APIs they need, so that we can work together.
And interoperability is the word. I know that. So thank you.
Thank you very much.
Have a
Thank you very much.
evening.